Sequences and progressions. A sequence is an ordered list of objects. It can be finite or infinite. The elements may repeat themselves more than once in the sequence, and their ordering is important, unlike a set. Arithmetic progression is a special type of sequence in which the difference between successive terms is constant. So the general term is given by an is equal to an minus 1 plus d is equal to a1 plus n minus 1 into d. ai is the ith term, d is the common difference, and a1 is the first term. Each of the following is necessary and sufficient for a sequence to be in APA. So ai minus 1 is equal to constant. If you pick any three consecutive terms, the middle one is the mean of the other two. For all I comma j greater than k greater than or equal to 1, ai minus ak by I minus k is equal to aj minus ak by j minus k. Summation. The sum of an infinite AP can never be finite except if a1 is equal to 0 and d is equal to 0. The general sum of a nth term AP with common difference d is given by n by 2 into 2a plus n minus 1 into d. The sum formula may be rewritten as n into average of a1 comma an is equal to n by 2 into first term plus last term. Examples are all odd positive integers 1, 3, 5, 7, a1 is equal to 1, d is equal to 2. All possible positive multiples of 23, 23, 46, 69, 92. a1 is equal to 23, d is equal to 23. All negative reals with decimal part 0.1. So minus 0.1, minus 1.1, so on. So a1 is equal to minus 0.1, d is equal to minus 1. Geometric progressions. It is a special type of sequence in which the ratio of consecutive terms is constant. The general term bn is equal to bn minus 1 into r is equal to a1 into r to the power of n minus 1. bi is the ith term, r is the common ratio, b1 is the first term. The sum of an infinite GP will be finite if absolute value of r is less than 1. The general sum of an n-term GP with common ratio r is given by b1 into r to the power of n minus 1 by r minus 1. If an infinite GP is summable, mod r less than 1, then the sum is b1 by 1 minus r. Harmonic progression is a special type of sequence in which if you take the inverse of every term, this new sequence forms an AP. Of any three consecutive terms of a HP, the middle one is always the harmonic mean of the other two, where the harmonic mean is defined as half into 1 by A plus 1 by B is equal to 1 by HM of A comma B, or in other words, HM of AB is equal to 2AB by A plus B. APs, GPs, HPs, linkage. Each progression provides us a definition of mean. Arithmetic mean is a plus b by 2 or a1 plus so on plus an by n. Geometric mean is root ab or a1 into so on into an whole power 1 by n. Harmonic mean is equal to 2ab by a plus b or n by 1 by a1 plus so on plus 1 by an. For all non-negative real numbers, am greater than or equal to gm greater than or equal to hm. In particular, for two numbers, am into hm is equal to gm into gm. For example, let a is equal to 50 and b is equal to 2. Then the am is equal to 50 plus 2 into 0.5 is equal to 26. Gm is equal to square root of 50 into 2 is equal to 10. hm is equal to 2 into 50 into 2 by 52 is equal to 3.85. AM greater than GM greater than HM. So AM into HM is equal to 100 is equal to GM square. Let us look at an example. A coin is tossed repeatedly till the result is a tails. What is the probability that the total number of tosses is less than or equal to 5? So P of less than or equal to 5 tosses is equal to P of 1 toss plus so on plus P of 5 tosses is equal to P of T plus P of HT plus P of HHT plus P of HHHT plus P of 4 heads and 1 tail. So we know that P of H equal to P of T is equal to 0.5. So probability is equal to 0.5 plus 0.5 square plus so on plus 0.5 whole power 5. This is just a finite GP, but first term is equal to 0.5, n is equal to 5 and ratio is equal to 0.5. Hence probability equal to 0.5 into 1 minus 0.5 square by 1 minus 0.5 is equal to half into 31 by 32 by 1 by 2 is equal to 31 by 32.